Welcome to Module 5.3, looking at Chapter 7, Basic Algebra, and we will be reviewing how to solve simple equations. And this might be a review for some folks. So to be able to solve a linear equation in one unknown and to solve formulas are objectives for this very short introduction. So what we're going to do is look at equivalent equations and just think about what is an equivalent equation. And the key to just remembering an equivalent equation is that it is equal to, and so remember that this is equal to something, in this case 2x plus 7 is equal to 13. So that says whatever 2x plus 7 is, it's 13. And same thing for over here, 3x is the same thing as 9. And so it's a jump in algebra, and it's one of the things that if the teacher didn't go over it with you when you were in high school, that it might not make sense. Go, gosh, oh, these algebra, the letters and coefficients in this completely different foreign language. Basically, just remember that when you're talking about an equation, that it is something equal to another. So when you are balancing an equation, just like anytime you would have something that would be balanced, your checkbook, your credit card statement, so it balances hopefully down to 0, that what you want is you want to take, if you take one thing from one side, you have to take it from another. If you add things to one side, you have to add it to the other. And so that's key with an equation. So let's look at this, and we're going to do an equation that is a substitution problem. And so go ahead, and if you'd like to stop the video and try this one on your own first, remember to reread it before you attack the problem. Okay, we're back, and so let's go ahead and look at this example then. And so in this case, we see that a conveyor belt, which is the letter C, is measured in metric tons per hour, and the variables in this problem are S is the belt speed, D is the density, and A is the cross-sectional area. So let's look at the problem then and see what it is that we're given. And so we can see that we have a density of 750 kilograms per cubic meter. We have a cross-sectional area of 0.083 square meters. And so it's asking, the question is asking, what belt speed? So it's looking for speed. So this is going to be the variable that we are looking for. So we're going to go ahead and do this problem and use the substitution method for it. Again, I like to bring down my formula so that I can work with it. 3.6 times S times D times A. And so let's substitute what we know. We know that the cross-sectional area, well, just a second actually, let's see, and it's, oh, we forgot I forgot something in here that we know already about this problem, and that is that we need to move 1,000 metric tons per hour. So that's the conveyor, that's the rate for the conveyor belt in metric tons per hour. So given that we have that piece of it, let's go ahead and we have C, so we're going to say 1,000 equals, let's see, we're going to bring down our 3.6 as a constant. Remember, S is what we're looking for up here, so we're going to leave that as a variable. Make sure that you don't confuse that with a 5 later on. S's are kind of problematic along with O's and some other numbers, I, when you're using those for variables. Remember, that's an S and not a 5. D, we have the density of 750. And we have a cross-sectional area, A, as 0.083. And we can put all these into parentheses if it helps you, or you can have it to where it's just 3.6s and then 750 times 0.083, or let's see if that helps a little bit. And let's go ahead and bring this down a little bit farther. Extend my page. And we're going to say that the, let's see, we're going to go 750 times 0.083. And that's going to be 62.25. And then we have 3.6, and then times s. So let's go ahead and multiply 3.6 times 62.25. And we'll have 224.1. Get that actually. That extra point there. And we will have 224.1, and this will equal 1,000. Remember, it's an equation, and this is times s still. And so now we have 224.1 times s. So to be able to isolate your variable and get it by itself, you do the opposite operation. So 224.1 s divided by 224.1, and then what you do to one side, you have to do to the other. And so let's go ahead and clear this and go 1,000 divided by 224.1, and we end up with s equaling 4.46 when we round, because remember we're an action, and that is your final answer, and that is given in, that is the speed in meters per second. And so this material moves at 4.46 meters per second. There we go. All right.